MP homework number 4, 15.7. Figure 1 is the position versus time graph of a particle in simple harmonic motion. What is the phase constant? What's velocity at 0? What is velocity max? Looking at figure 1, the knowns we can pull out are the period, t equals 4 seconds. We can pull out amplitude, which is 10 centimeters. And we can also just go ahead and solve for the angular velocity, which is 2 pi over t. That's going to equal pi over 2. So back to figure 1, we're starting at 0 seconds. At 0 seconds, our x position is at 5 centimeters, and the particle, or the wave form, has a positive velocity. Looking to the unit circle at x equals 5 centimeters, we know because our slope on our figure 1 is positive that our velocity is positive and the angle we need should be in the 4th quadrant. SOHCAHTOA, inverse cosine, and our phase constant is negative pi over 3 radians. Part B. Find velocity at t equals 0 seconds. We'll use this formula here that you can find in the book. And so when looking at this formula, we're going to need V max, so we're going to solve for that first, which is our part C of this question. But we're going to do it anyways. So V max is angular frequency times amplitude. Our amplitude was 10 centimeters, and we already solved for angular frequency, which was pi over 2. We get 5 pi centimeters per second as our velocity max. Now, when looking back to our equation to find velocity at t equals 0 seconds, we have everything we need. We have V max, we have angular frequency, we have our time is going to be 0, and we have our phase constant, which was part A. Plug it all in, and it equals approximately 14 meters per second. Centimeters per second, sorry. Now, let's assess it. Part A. Is pi over 3 radians reasonable for our phase constant? So the position x equals 5 is positive. So that means our particle will be in either Q1 or Q4, and the positive velocity tells us it's Q4. So negative pi over 3 radians is reasonable. Part B is 14 centimeters per second, a reasonable number. Well, our velocity max was 16 centimeters per second, and our velocity max is at the position x equals 0. So any position on figure 1 other than 0 has to be less than our velocity max. Thus, everything's looking fabulous.